to check the function behavior. There are two types of assertion: immediate assertion and concurrent assertion. So
Okay.
immediate is it means immediately we will check, and concurrent means with some clock, basically clock edge, and we will check some conditions based on some timing using implication operator. It can be overlapping or non-overlapping.
Okay.
So that's it.
Okay. Pages, will you try?
Sure, ma'am. Ma'am, in immediate assertion, we generally use a keyword known as assert,
Yeah.
whereas the assert will generally check for whether the given condition will be a true or false, like depending on the clock pulses.
Okay.
And in concurrent assertions, we'll be having certain blocks like property sequence and
So don't we
yes.
hazard in concurrent assertions? We use assert in both immediate assertion and concurrent assertion, or we will use only in the immediate assertion?
So in both we will use assert statement.
Yeah. Okay. Okay, so let me clarify for all of you once again, because that is the frequently asked question actually. What are the different types of assertions and what exactly the difference is between the immediate assertion and concurrent assertion? So once for all, I will clarify. So we know that the assertions are basically for to validate the behavior of the design dynamically for the entire simulation. So at each clocking event, whatever conditions we provide, at that conditions the assertions will be evaluated and it will be given as a passing or failing. This we know. So in that we have two types of assertions basically. One is immediate assertion and the other one is concurrent assertion. As in the name itself, it says that immediate assertion means the assertions will be evaluated immediately. So these can be included inside any procedural block or somewhere. Where the immediate assertion, for example, we have the assert keyword, right? Assert and just will give the expression over there. So there will be only the expression and it will be immediately evaluated there itself. So in the immediate assertions, the assertion evaluation, whatever expression we provided, that won't be over the sequence of multiple clock cycles. Only at that particular passage of the clock, the expression, simple expression will be there, that will be evaluated. So can you guys, anyone tell what is the example for the immediate assertion in system Verilog, UVM we use that, one of the assert keyword we use it. So can anyone say which is a proper example for the immediate assertion? Just give it right. It's okay if you guys go wrong.
We can write like that in assert. Assert we can write A and B, like
Okay.
and operation between.
Okay. Okay. What about others? Kiran, I think you are about to tell. Yes.
In randomization also we are using asset keyword.
Yeah, yeah, correct. So that is the main example which I was looking for. As set of S dot randomize we do, right? In the before then we saw for the coverage in some codes we had written, right? We will write the S dot randomize. We'll create the class object and using that object we do dot randomize, right? So that is an example for the immediate assertion. So in that, what it is doing, it is not giving any clock cycles or over a range of period. It is not giving. It is just giving like S dot randomize, right? Who is this? My wins. Uh, who is this? My wins. Hello. Okay, so the immediate assertions we have like that, right? So assert or randomize when if the randomization is failed, so it will give us the error in runtime itself, right? That the randomization has failed. So that is an example for the immediate assertion. What is the concurrent assertion? Means the concurrent assertion is basically which is spread over the multiple clock cycles. The assertions will be evaluated concurrently, means parallelly the assertions will be evaluated. And the thing is here in the assert, you will use some property. You will give some sequence, and the sequence you will use in property, and then you will write assert of property, because that is spread over the multiple clock cycles, right? So you cannot write in a single statement. That's why you are creating a property, and inside the property you are giving some. This is a simpler statement, but there could be some complex things also, right? Where it will be tough for us to do at the single shot. So that's why we have different sequences and properties. So here you will use assert property posage clock, not of A and B. So here what is it doing? It is at the property is getting asserted, means it is getting triggered at the posage of the clock, and it is checking first A and B means A should be high and B also should be high. Both should be high. But then we are providing an thing called not. So it means it should work as reverse. Means A and B should be low. At that point, this assertion will pass. In other every instances, the assertion will fail. Okay. So that is about concurrent assertions and immediate assertions. This is the basic difference. So in immediate assertion, you will not use the property and all. You will just write assert and the expression. And in concurrent assertion, you will use the assert with property by giving some clocking event, and the assertion will be spread over the multiple clock cycles. So this is the basic difference between the immediate assertion and concurrent assertion. Is it clear for everyone?
Yes, ma'am.
And so in concurrent assertions, we have Abhishek, you were about to say something.
Ma'am, Boolean expression we cannot write in immediate assertion.
We can write it Boolean expression like A or B, simple things which will be evaluated at only that percentage of the clock. We can write it. In the concurrent, what is not possible at the immediate is over the multiple clock cycle. Like yesterday we saw some examples, right? A after 2 clock cycles, B after 2 clock cycles, C should be high. After 2 clock cycles, D should be high. That way you cannot provide it immediate, because that will take time to get evaluated, right? That is for entire sequence. So if it is like A and B, this is a simple one. At that it will just at that percentage of the clock it will check that whether A and B both are high or not. So those things are come under immediate. So when there is a requirement where you have to evaluate the assertion over multiple clock cycles, basically over a period of time, in that case you will choose the concurrent assertions and try to write a concurrent assertion for those things. Is it clear, Abhishek?
Okay, ma'am. So if period of time, for a period of time, always concurrent assertions will come.
Correct.
Okay.
Yeah. And so, so we saw all this. So this is like we saw, right? For the concurrent assertions, we have something like we have split it into the building block of SPA water. It is means like we'll create a Boolean expression. If it is very complex, we'll create a sequence, and that sequence will be putting it inside a property. And like how in coverage we have a sample method, likewise in assertions we have assert. When we write this assert of property, then only the assertion will take its action in the environment. Otherwise, writing a property, writing a sequence of no use. Okay. So just remember all this. And we also discussed how many types we can give the clock. So we can give the clock in the sequence also. We can give the clock in the property also. Or we can give the clock while directly giving the assert property, or we can give the clock using a clocking block. In some interface, we can define some clocking block. That clocking block you can use while taking the clock. So that way also you can do. So we had already discussed that why we need like the clock in the sequence. When has we have to prefer to write the clock in the sequence, when we have to prefer to write in the assert or the property. That is because whenever you want to increase the reusability, then you should not provide the clock in that particular sequence. Rather, you can reuse that sequence in any of the properties where you want to, where you can customize your whatever thing things by giving the clocks, right? So if you provide that at the sequence itself, so if you want to use that sequence in the property, then if you want to do it some luggage operation or something, then you can't do it. Again, you have to create one more sequence, and that sequence you have to use. So to increase the reusability, it is preferred to take the clock inside the property instead of sequence. So this is what we have discussed so far. And we have also discussed some of the property, some of the operators, right, in assertions. Like we have seen, like how the Boolean expression. This is, we all know the logical operators, that is logical or logical. And like this, we saw already and B, and this logical or if it is equals, this comparison. All these things are very simple. It will be self-explanatory, but still we have saw how the things are going. Okay, and then we also saw the system functions, right, that we will discuss about. So these are the methods and these are the built-in functions. So we didn't discuss about this built-in functions. So let us discuss about those. So dollar count once is basically like you can give the argument like this, dollar. You can give the argument like dollar count once. Suppose A or right, let us think address, okay? So I want to I want to check the address where the dollar count once of address is only, you can provide anything, okay? It's not like it should be. Basically, this count once function, what it will do is how many number of ones in this particular variable which you are providing in this space. Okay, here I am providing the address for suppose. So in this address, whatever addresses at the position clock, I want to check how many address, how many ones are there in that particular address. So then I will use this and figure out what are the number of ones, and I can store in some variable, and then I can use that variable somewhere else where I want to evaluate whether it is according to my requirement or not. So in order to use in such requirements, this dollar count once is necessary. So basically what you have to understand is what is the functionality of dollar count one is to count the number of ones in that particular variable. So the address for suppose 32-bit address is getting randomized. In that 32-bit data, how many number of ones are there, that you can figure out with this. So that you can use in different ways. Like you can try, like for suppose I have a requirement. For suppose we have like address, and I want like only some 3 bits should be 1, others should be anything, it could be 0, I don't care about it. So so in that case I can give like dollar count once of address is equal to 3, and I can write an assertion in such a way that it will check at every passage of the clock the address value has number of ones as 3 or not. When it is having 3, it will pass, otherwise it will give me the failure where and wherever this is violating at that particular time nanoseconds, it will give me the failure, otherwise it is pass. So like that it is. So likewise we have different system functions, so let's go through that. So this is done. Then the dollar is unknown. Dollar is unknown is nothing but like the same syntax we have in that particular variable. For suppose it is due to some condition, it is reaching to an x value. So in that case, it will give us the dollar is unknown will return the function as return the value as 1. So in that case, I will understand that my variable is going to x. So that is, if suppose I want to track that it shouldn't go to x, based on that I will write my assertion. I will write like if it is returning 1, the assertion should fail. If it is returning 0, the assertion should pass. So likewise, I will write so that I will track the variable is not going to an unknown state. Okay. So then $1 hot and $1 hot 0. $1 hot means only one variable, one bit of that particular variable should be high at a time. Others should be 0. That is $1 hot. This one, $1 hot 0 means either no bit should be high, or at least only one bit should be high. So all zeros could be, or only one bit should be high. That is $1 hot 0. So can anyone tell me this $1 hot where can be used in any of the application? For example, what you are getting in your mind. Where can I use this $1 hot to make your evaluation simpler? Fine, that's okay if you don't know. So if there is a communication between master and slave in any of the application, so I have a requirement like it is only one master to one slave at a time it can happen. So if I have some n number of slaves, for certain constraint we can use one more. Okay. So if we have n number of slaves, some 5 slaves, but I want to communicate with only one slave at a time. So at that time, I can use this $1 hot of slave, right? So it will only pick only one slave at a time actively. So in such scenarios, we can use $1 hot. Okay. And then the dollar rows we have already discussed yesterday. That will be like the transition from low to high. So this scenario, it will check through dollar rows, and dollar fell also we have already discussed, that is high to low, right? And then dollar stable is like the particular variable should not change its value from past. Means this particular clock cycle, if it is 1, and at the previous clock cycle it will observe whether it was 1 or 0. It was 0 and here it is 1, it means it will return 0 for us. If it has to return 1, it means like at the previous clock edge also the signal should be high, and this particular clock edge also the signal should be high. So basically it will compare it with previous clock cycle value and the current clock cycle value. And if there is no change in that particular value, then it is dollar stable will return 1, otherwise it will return 0. Okay. And then the dollar past is like it will not return 1 or 0 here. Basically, the dollar past will do, it has, you can provide the argument, for example, dollar past of A, comma 2. So it means it will check that before 2 clock cycles, what was the value of A. So based on that, it will, you can use that by storing it in some variable, and you can compare with some other things and you can use that. So this will not return like these three, 1 or 0, but it will give us what is the value of that particular variable in the previous clock cycle, whatever clock cycle number you provided here, and based on that you can store it in some variable and you can use it further. So if we see some examples related to all this, you will get more clarity. Okay. And Sudha, you missed this dollar count once, dollar is unknown. Dollar count once is like to count the number of ones in that particular variable. And dollar is unknown is if that particular variable is going to any of the value like X or unknown state. In that case, this will return 1. $1 hot means in that at a time, any variable should have only one bit as high. Rest all can be anything. Rest all should be either 1 or 0, right? So so at a time only one bit should be high. Okay, so that is the things which we have discussed newly today.
Okay.
Okay. And then
Hello.
any doubts? Yeah.
Ma'am, can you tell the difference between $1 hot 0 and $1 hot?
Yeah, $1 hot means any only one bit should be high at a time, and $1 hot 0 means it can be all zeros or any one bit should be high. So those both conditions it will return 1 here. Got it? Is it clear, Abhishek?
No, ma'am.
Okay. $1 hot means, for example, I have 3-bit variable. So here I have 0, 0, 0. Okay. And one more I have is like 0, 1. So now if I check like, and this is, for example, 3-bit variable A I have. So I can write $1 hot of A. That gives, when the value is 0, then also, okay, let me explain $1 hot. So when I have A and 000, it means this will evaluate to 0. Means because $1 hot will check only one bit should be high at a time. Okay.
Any one of it.
Any one of it. It could be here, it could be here, or it could be here. Only one bit should be high. Others should be zeros. $1 what it will check is either this should be the condition, any one bit should be high, or nothing should be high, all should be zeros. So these two conditions will come under $1
Okay.
only this condition will satisfy.
Okay, ma'am, got it.
Okay, then. So shall I move to the next part? Okay, now I took some examples to understand these functions were. So these are the real-time things, okay? So I have taken some today. We will discuss some more tomorrow. You guys first get clear with all these things which we have discussed today, and then we can go to the still more complex things. So here I am writing an, if someone asks you to write an assertion check to make sure that a signal is high for a signal, in the sense here the variable signal name is A, is high for a minimum of 2 clock cycles and a maximum of 6 clock cycles. So this is what my requirement is. Then how will you write the assertion? I am not writing the entire code because the main thing is lies under this property, right? So the same thing I have displayed for you all here. So we have created a property. Inside that, let us understand each and every word from this. With that only your understanding of different functions is how much clear or not you will understand. So if anyone wants to try, let us do as an interactive session. You guys can tell me, we can understand. Or let me do it for one and the next things you guys can do. So property and end property, and at the rate of passage of clock means this is the clocking event which we are providing. So at every passage of the clock, it is our assertion is going to be evaluated. Okay. And then there is something called disable if and only if. You all know, right? Just like in English, how it is IFF means if and only if, basically. So these assertions are very simpler to understand, but to create a tricky assertion is tough. But to understand which is already there is little easy only because it is just like a normal English, how we speak, the same thing it is. Okay, so at the passage of the clock, our assertion has to be triggered every time. At every passage of the clock, it will check for the sequence. Okay, so then disable if and only if means you are writing the condition like not of reset. So you are saying that if there is no reset, then this assertion will not be triggered. When the reset is high, then only the assertions will come into the picture. So if you want to mention any such things, you can put those things inside the disable if and only if. Okay, so that is what we have mentioned here. Disable if and only if there is no reset. Then we will write like $rows of A. $rows of A means we all know, right? Can anyone tell what is $rows of A means?
If A
Transition
is
from
high, sorry.
When the value is going from 0 to 1, we will have scaling.
Yes, correct. So we are checking. So this assertion will take place only when it finds the scenario where A is going like this. A is going like this. Okay, this is A, I suppose. At this point only the assertion will start evaluating. Then we have taken something called implication operator. What is this implication operator is? There are two types of implication operators basically. One is overlapping implication operator, the other one is non-overlapping implication operator. So if it is an implication overlapping in the sense, for example, this is the clock cycle. So at here I have written some condition. Implication is basically like if else, if of condition will write, right? If that is evaluated to true, then only it will go inside the loop. In the same way, the implication is also the same. If the A is 0 to 1, then it will go inside. But if it is a overlapping, it means that, for example, here the signal A is go at this passage, the signal A is going like this from 0 to high. So at this point only it will start evaluating the further part of the sequence also. If it is non-overlapping, we represent that with this symbol. So this is called non-overlapping. This how it will do is, if now at this pauses the A is high, is going 0 to high, and then at the next clock edge it will start evaluating the next things. Means whatever we provided here, that will start from the next things. It will not consider from this clock cycle. So basically overlapping means from the same clock cycle. The non-overlapping means from the next clock cycle. So this is the basic difference between that. Okay. I've taken one more.
So
Hmm.
are they similar to immediate and concurrent? Like say even we have the same, like same cycle and the different cycle.
So immediate is basically, I have actually in today's session I've explained.
Hello,
Yes. Yeah.
Pragya. I am Anil Kumar.
Yes.
Here they are not mention any delay, right?
Yeah.
Why you are using delay hashes 2? Because the high for minimum 2 clock cycles and maximum 6. You can use only start 2 down to 0. You can use consecutive cycles. Why you are using again the delay 2 hashes 2?
And Anil, actually Sudha is telling something, right? You cannot interrupt that way. You have to wait until the others complete, right? You can ask your question, that's not a problem, but that's not the way. So please mute yourself. Sudha, you can go ahead. What was your doubt?
Okay. Sorry, actually I joined the class late. I thought it's 9:30 and I joined. So like my doubt was like this implication that overlapped and non-overlapped. Like are they similar like immediate and concurrent? Even they will be in next cycle and the same cycle. So is that?
No. Actually, immediate assertion means the clock cycles won't come into the picture at all. In immediate assertions, it will be something like the expression will be evaluated immediately. There we won't provide anything which will be spread over the period of time. So once I will share you the recording, right? So once you can listen to that, initially I have explained clearly. So let's not go over time. That's fine.
Sure.
Yeah. Anil,
Thank you.
can ask what is your I actually understood your query. Like here it was like a signal is high for a minimum of 2 cycles and a maximum of 6 cycles. So in that case, why did we take this hash 2, right? So actually this is not necessary. This is wrong. So you can simply write this thing. A should be high between 2 down to 6. So as they are asking from minimum of 2 cycles and a maximum of 6 cycles. So this will be enough to satisfy the statement. This hash 2 is was my mistake to include this here. So we don't need this actually. Okay. So where were we? We were discussing about the dollar rows of A, right? The dollar rows of A is basically 0 to high. So at that point, we will check that. So if it is an overlapping at the same clock edge, it will start. Means now in the same clock edge, it will start in the sense the A should be high for what is that? A signal should be high for a minimum 2 clock cycles to maximum of 6 clock cycles. So you are using some repetition operator here, which is like we are checking like at this posage the A should be high means for 2 clock cycles, right? Means this A should be high 1 2. So till here it should be high, or it should be up to 6, right? So we will give this way 2 to 6. So it can be any number of clock cycles. If it is till here also it is high, then also it will be evaluated to true. And if till here also it will be evaluated to true. And from here also it will be evaluated to true. So likewise, and one more, I think 1, 2, 3, 4, 5, 6. So till here, if somewhere here also it is extending and it is still high, it means at this passage of the clock, it will get evaluated, and here it will give us the failure. The assertion is failed. Till here it will show it the assertion is passed, but at this point the assertion will be failed. Okay, is it clear for everyone? Hello.
Ma'am,
Yeah.
ma'am, what is the meaning of the start to?
This is repetition basically. Means how many times the thing A has to be high. This here is just we are giving A, right? It means this signal has to be high for how many clock cycles. So basically this star is nothing but the repetition. How many times this has to be repeated. This has to be high for how many times? So 2 to 6 means 2 to 6 clock cycles basically.
Okay. So ma'am, if I put that star,
Hmm.
I can put on 6 also.
Yeah, no. Here I'm giving the range, right? That's why here. If you want to directly check for only 6 clock cycles, then you need not provide this range. You can just give 6, star of 6. It means the A should be high for 6 clock cycles.
Okay, that is exactly 6 clockwise. Yeah.
Fine.
Hello.
Yes, Anil. Yeah.
Yeah, we can use direct A, right? Why you're using without dollar symbol rows also we can write, right? It's an antecedent part, right?
See, if
So if it is A is high at that time, that consequent part it will be working, right?
yeah, see, yesterday class, if you hear, you will understand. Like, if you write simply A, it means the A should be high from the previous clock cycles. Means here also it could be high and here also it could be high. But here what I am trying to do is I want to check from the assertion from 0 to 1. If I want to have that way, in that case we need to use dollar rows of A. Here it is not like very specific requirement. If the A is high also fine, it is not previous. There could be some scenarios where I mentioned like at this point only I want to check from 0 to 1. So both will work actually. Dollar rows of A also will work and A also will work. But dollar rows of A will work only when if it is like 0 to 1, this transition is happening, then only it will work. Is it clear? You got the difference between the A and dollar rows of A by having. Hello.
Okay.
Yeah. So let's go to the. Yes, shall we rejoin the session because the meeting is going to be end. Yes, please.
Hello ma'am, one doubt ma'am.
Yeah.
Ma'am, see, you said like when dollar rose, like
Hmm.
when A is going low to high,
Hmm.
at that time it will start evaluating the other one.
Hmm.
After one clock cycle, that A will again go low. Then what will happen?
Then see here the
Because it's
entire thing is related to this A only. So first at the positive of the clock, the A is you said that this condition is there 0 to high, and next clock edge it is going low. So this is not ending here, right? Here when it is like A is going low to high, then you have the next sequence of operation also related to A only. Like it has to complete this entire sequence once, and then only for next passage of the clock, again it will check this rows of A. So that's how it happens.
for two consecutive pause edge, the dollar rose like it should be go from low to high.
No. See, forget about this requirement. Only this whatever sequence is there that we will work on. Okay. So now the A is 0 to high. The first one is at the positive of the clock if there is no reset. Let us assume that there is no reset here. Reset is low. And then it will check like A is going 0 to high. Okay. And then the evaluation starts. And then what is there after 2 clock cycles? Means till 2 clock cycles. Okay. So here this is the positive, this is the negative, this is the positive. So 2 clock cycles, it will not check anything. Okay. After 2 clock cycles, it will check that. And here the A has to be high. Okay. So at this time, the A has to be high. I have written, right. So it means that it will not check from 0 to high it is going or not. It will just check that at this positive of the clock A is high or not. Okay. And then what did I mention? A has to be high for 2 to 6 clock cycles, right? So if suppose my A is high for 2 clock cycles, 1 and 2, and here this positive went down like this, okay? So it means this will this assertion one sequence is done, means one time this entire sequence got executed. At this positive of the clock it is going low, that is okay, because the A has to be high only from 2 to 6. So one possibility 2 to 6 in the sense at least 2 you will say, right? That will come here. At least means what? 2 or more. At most 2 means 2 or 0. Likewise, here 2 to 6 means either 2 should happen, if this will evaluate it to true, and here it is done. Again, it will check if the next posit. Here at this posit also it will see whether is A is going from 0 to high. It is not going, right? So here it will not check. Here also it will not check. Again, here if my A is going high like this, so here it will start checking. That way it will happen. So in between, if A is going low, that doesn't matter. It will only work on this entire sequence, how it is happening. Is it clear?
Here in this question you are considering that SS2 also.
No, see, I told now, forget about requirement. Let us analyze this. You just want to understand how it works, right? We don't need this actually. But I'm just explaining you according to this sequence how it will work. First, you need the understanding of how each operator will work. Then we have to think about the requirement. But for this, this answer is wrong. #2 is not necessary. That I agree. But I am telling like this is the proper understanding how the sequence will work. Your question was what? When it is high and in between if it goes low, how it will work. So for that I am answering now. Got it?
Okay, ma'am.
Yeah. Then let us go to the next one. So here I have taken one more example. At the rate of positive clock request, after that we are giving non-overlapping, and after clocks, 2 clock cycles, I am checking the acknowledgement is high or not. And one more thing is I am taking one more implication operator. This is overlapping implication operator, and I am taking this. So I wanted you to all to understand whether this overlapping and non-overlapping concept is clear or not. For that, I have taken two different statements. So I am asking you guys, like these two statements give the same output or it is a different output? Are you getting my question? Hello.
Same
Not
output, ma'am.
not same.
Same, ma'am, same.
Okay.
Same.
Not same.
Not
Same output.
who told
Yeah, I think
Anshul, right?
Sorry, your voice was humble.
Who told not same? Anil, I guess, right? Can you explain, Anil, why it is not same?
So both statement you asked me, right?
Yeah, both the statements.
Yeah, because of that implication operator, that is, you can use overlapping, non-overlapping, right? When you're using single cycle operator, it will be only single thing. Whenever request is high, at that time only that dollar symbol rose only the present clock symbol after 3. But here it is not like that in the first statement. It's a double cycle operator.
Your answer only has the answer, but still you are telling the wrong thing only. How I don't get it. This both output will be same because this implication here it is giving, we are using 3 clock cycles. As here it is overlapping, it will start from that particular clock edge. But here it will start from the next clock edge, right? That particular clock edge it will skip and it will do it. So that's why even here we have used non-overlapping, and that's why we have taken 2 clock cycles. Here by using overlapping we have taken 3 clock cycles. So these both statements state one and the same, right? So how is it the output is different? The output is same. Just to clarify our understanding, I have taken these two different statements.
So it's like basically overlapping with one delay is equal to non-overlapping, right?
Correct. To get that equation,
Yeah.
I have taken this. Supriya, is it clear?
Ma'am, so here after 3 clock cycle in both, it will check dollar rose is high or not, right?
Yeah, yeah.
Okay.
After it's not like after 3 or 2, which you have to understand here. Let me clarify once again, because this is
Ma'am, got it. Okay. Because of overlapping, non-overlapping, the difference, one cycle difference will come.
correct, correct. Mhm.
Got
Fine. And then let us move to the next question. That is, write an assertion checker to make sure that an output signal never goes X. Means we have already gone through the dollar is unknown system function, right? So what does it do? Or it will check that particular, here I have shown you the syntax, right? Dollar is unknown of output signal. So this output signal, whatever is there. So here we haven't declared it. This just to understand, here it is given output signal, no? So based on that I have taken. So the output signal should, when it will return, the dollar is unknown as 1, and when it will return as 0. Tell me that, any one of you. When this function will return me 1, and when this function will return me 0. In what case?
1 xz, these all cases are written 1. 0, yes, 0 will become.
Kiran, your voice is breaking. Can you please repeat once again?
1 xz, these all conditions are result 1.
Mm-hmm.
Only 0, result is 0.
No, it's wrong. Someone else?
If there is no X or Z at that time, at that time output will be high.
Okay. No X or Z, or any X or Z is there? Actually, you told the reverse. If there is any X or Z in that, then the dollar is unknown will return 1. When if there is no X and Z, it means that the dollar is unknown will return 0. Okay. So now what I want is the output signal should never go to X. In that case, I want the total output as 0. So that's why I have taken not of dollar is unknown of output signal. So never in the writing this kind of assertion, at every passage of the clock, it will check like in any of the signal is going to X or Z. It is going to some X value. In that case, the assertion will fail. Otherwise, the assertion will pass. Okay, so this is how you have to analyze, and you have to use your system functions, whatever knowledge you have so far, and you have to write your assertions. Now the next question. The signal A and signal B may only be asserted if signal C is asserted. So this kind of scenario we have to write. For now, you guys can ignore this part actually. Hmm. Hmm. For now, you guys can ignore this dollar. Is changed or something, that it is not necessary for now. You guys can only still see till here. So what it is saying is the signal A and signal B may only be asserted if signal C is asserted. In that condition, what you should do? First, you have to pick for the signal C. Where the signal C is asserted, then only you will check for signal A and signal B or high or not. That will also serve the purpose. It is not a rule that here it is given like first about signal A and signal B, then only the signal C. So first you have to write the condition for these two. That is not the rule. So you can write it anyway. For this particular requirement, if 5 people are there, 5 people can write 5 different solutions. So am I recording or not? Yeah. So there can be 5 different solutions. So that way it will work. Everyone can use their own creativity to write an assertion, just that it should be very optimized way. And it should be useful for the use purpose. That is the main thing you have to keep it in mind. And you can write any creative way as the assertion can be. So here what I have taken is, if the signal is C is asserted, at that point the signal A and signal B should be high. So that is what I have written here. At the positive of the clock, disable if and only if there is no reset. Here also, when there is no reset, then only I want to check my assertion. So that is what I have mentioned here. It's not that you have to mention reset only here. There could be some conditions. For example, there is some variable called A, and at the place of A, you don't want to check. In that case, also you can write like not of A. Or you can use the signal C and B and signal C also here. Like when signal C is high, then only this has to be checked, right? So you can write when signal C is 0, then you don't want to check anything. That way also you can write. Okay. So what is this? These two should be high only when signal C is asserted. So this is, I told, right, there can be n number of solutions. You can try different ways. So here this is one of the way where I am writing like signal C. This is the implication operator which I am using. This is a overlapping, means from the same clock edge it will start evaluating and check like from that clock edge the signal A and signal B both are high or not. If that is high, then the assertion will pass, otherwise the assertion will fail. So this is how the entire evaluation is done for the assertion. So this thing you can, is not necessary actually, this unchanged or changed. So that is, you can ignore. So till here you guys can observe and try to understand all these concepts of assertions which we have discussed so far, and try to see the questions which we have discussed so far. So I will get some more questions tomorrow. We will discuss. Before that, you guys get familiar with all the system functions, methods, what are the different operators we have discussed so far, what are the different types of assertions we have discussed so far, so that we can start with some more complex questions. So tomorrow it will be entirely Q&A, like how we had done the last session for coverage. In the same way, we'll do one more session for assertion where we will just have a Q&A. So if you want to participate in Q&A session very actively, it means that you should be having a good knowledge of what all the concepts we have covered so far. So you guys go through it. If possible, I'll share the recordings tomorrow morning, so that if anyone has missed it, you guys can go through and come back to tomorrow's session. Okay. So that's it for today. Let us end.
Hello. Hello, ma'am. One doubt, ma'am.
Yeah.
Ma'am, in implication operator, when we are using,
Yeah.
at that time, like signal C is there. So first we will check signal C should be high. Then we will go to check that right side,
Yes.
like that AND operation.
Yeah, when left side one
Okay.
is evaluating to true, then only the right side one will we will start evaluating. If the left side one is not evaluated to true, it will not go for the further right side operation at all. So that is
Okay,
like
okay. So, ma'am,
operator means basically.
okay. So there are chances to fail like that. If a signal C is low, at that time only it get failed. Either if signal C is high, and after that it will go and check signal A and B. If anyone is low, at that time also it can fail, right?
Correct. The second one which you told is correct. The first one is when signal C is low. At that point, it will not check the further at all. So there the assertion will neither, the assertion itself will not get triggered. So it will not give either pass or fail there. Okay. So it will
Okay,
do
okay, okay.
the proper
So
instance.
at that time not getting evaluated.
Yeah,
Okay, okay,
correct, correct.
okay.
So here, can we write conditional statement also, ma'am? Like only if C, yeah, like if only the condition is true, then only it evaluates the statement. So
That
like,
is
can we?
means actually this signal C, and then you are writing the implication. No? That means you have some condition. So whatever condition you
Okay.
give, that you will give before that implication, and whatever. For example, we have the if statement, right? If loop. So what is like,
Yeah.
if of some condition, then you will write some dollar display. So when the dollar display will print when the if condition in the condition is evaluating to true, then only, right? Otherwise,
Yes.
it will go to the else part. It will not go to the if condition at all. Likewise. So basically, it is a conditional thing only. We are using an implication.
Okay.
Okay. So all these concepts you just will go through, and we will come back with the next. Actually, I am getting late, so tomorrow we will discuss. Okay.
Ma'am,
Yeah.
what about non-consecutive, consecutive go-to repetition operators? Operators means not only implication. There are so many operators are there. And what about bind keyword, binding?
So whatever the things I have covered so far, you guys go through that. And in the assertions today, I have explained one of the operators, that the star is one kind of repetition operator. We have so many different type of operators that even I am aware of. But for this workshop, it is a limited time. So based on the examples, wherever the example is so disable, if I keep on sitting and explain each and everything, that will not end in this 10 days. So that's why I have taken some examples. So in the example, in the flow itself, wherever we get such kind of scenario, I'm trying to explain. So with that, you can cover the practical example also, and you can also cover the theoretical explanation of that particular operator. So just hold on. Tomorrow we will cover some more examples. So you will cover some more concepts also, I mean some more operators also. So you can always learn. It's not like whatever is there, whatever I am telling, that is only related to assertion. That's not the case. For assertions, we have so many things. Everything cannot be covered, right?